Hello guys, and very welcome to this video. So now I have done some tests to this Volkswagen Golf Citystromer, and I can say that it has been really cold. So I have now decided to build the heating system to it, or actually it's already done. And I have been free from work this whole week, so I have put in a lot of hours to this. So what I have done there is that I bought a heater from a Volkswagen e-up on 5 kilowatt at 350 volts, so pretty good power there. And here is the control board that are CAN bus based, so I cannot use anything of this at all. So I decided to hook up some components to my breadboard here and trying to build a voltage divider that will control a transistor, and that transistor will then control a relay. And I cannot use a normal relay here because we are talking about high voltage and DC power. So you will not have a normal relay. I just have that for testing here, and later on I am going to have a high voltage magnetic arc blowout relay. And here's the heater opened up, and you can see that it is actually 3 elements inside of it. So I am going to use all 3 of them. And then you also see that up here in this left corner we have the thermistor to it. So this thermistor here will then replace the potentiometer that I have on the voltage divider here on the breadboard. And now I also need to make everything a lot smaller because I cannot have this breadboard hooked up somewhere in the engine bay here. So no, it needs to be a lot smaller than that. Hope you like it, guys. Let's roll the video. Here we go. Great, it is working. Now I just will measure the resistance that we have over the potentiometer, so I know that we are in the correct range. And around 1.4 kilo ohm to 1.8 is what I am looking for here. So first, of course, I need to disconnect the power, because you can never measure resistance with the voltage applied to it. To that circuit you are going to measure. So let's see if I am doing correct here now. Yeah, that's right, spot on. Perfect. So this will be around 75 degrees on the water or coolant that will go into the heat exchanger. So let's try it with the Nissan Leaf relay and see if we have that one to work at the same resistance. If not, I need to adjust the resistance. So it's good to know that before I do anything else here. So here we have the relay that I was talking about earlier. And here are the mic. Okay, let's put it on me instead. Alright, let's apply the power again. So negative on the negative, of course, and then we take the other one on the positive, and that is here. Okay, so let's adjust the potentiometer. So I hear that it barely wants to release it. So that's what I am concerned about here. If you listen here. Don't know if you can hear it, but that sound is the sound of a weak magnet field inside of this relay here. And when I am drawing amps over these contactors inside of this relay, I might have some arcing there. So that's the bad thing with this circuit. If I had a microcontroller that take care of all of those signals here, it will completely put on 12 volts here and then remove that, so it will be 0 volts, and the relay will open up, and you will not have this kind of noise or arcing. But still, the resistance are changing pretty much in the heat exchanger there, so I think that I might try this anyway. Maybe that's stupid, but I don't have any other option now. We have to see if this works. It maybe works better than expected. The worst thing that can happen is that the fuse will blow or the relay will burn up, and that's not good, of course, but it will probably not be too bad. So let's hope for the best there. And I forgot to measure the resistance there on this relay, so I have to do that too, of course. 1.4, so that's pretty good. It means that it will turn off a little later, but that's perfectly fine. I have measured it to 75 degrees at 1.4 kilo ohms, so we are still having some room up to 100 degrees there. Great, then we know. And by the way, we had some freaking snowstorm going on yesterday, and we were expecting a lot of sun today, so I had hoped that I could do some test driving today, but the roads are filled up with slush, so I will not do that. I have cleaned my solar panels, as you can see. We now have around 0 degrees here, so the snow was really easy to remove from the panels there. So yeah, it's good to be inside and take care of the heater to the car. Even if I'm not going to drive in snow with this car, there is still pretty cold during the spring and autumn here in Sweden, and even in the summer. I mean, in the summer evenings there we can have around 10 to 15 degrees, so we still need some heat, and as I said there, we need that to make this car road legal. So let's keep on working here. So my plan now is to remove this one, or change this out to the Nissan Leaf that I have here. So I have already drilled away those bolts here. It's a kind of security bolts, as you can see here. And one of them are totally corroded together with the casing here. So I am just going to file this down. And then I am going to open up this hole here a little bit, because this one is a little bigger than the one from Volkswagen here. And this is the cable that will lead into the thermistor, and you will have the inside here. So I have connected, it's 2 thermistors inside of this package. I am only using one, and I decided to use the upper one because that's usually where it's be hottest. So if the circulation pump or something stops, the heat will be in the top of this package here. So I think that this is the best way. Of course I could use 2 of them, but I don't have the electronics for it. So, and we also have 3 heating elements here. So this one is the biggest one. I think that this is around 2.5 kilowatt, and then we have 2 upper ones here, and I think that one of them is 1.5 kilowatt and the other one is only around 500 watts. So now I am using all 3 of them. I think that I might will remove one of them because I don't want to draw too much current through this relay and through this system. I will change that later on. I have not decided how to do it here, but we come to that later. So I will start to grind off this bolt here and then open up the hole a little bit. Okay, so now that's removed. I think that I will put this connector somewhere around here. Yep, so I need to open it up in this corner here, and this or end there, and the other one here. So I need to do this hole a little wider. That's pretty much perfect. So now I just have to drill 2 holes and thread it up with 6mm threading, I guess. Yeah, 6mm will be good. Alright, I see one problem pretty much immediately here, and that's that I am going to hit that bolt that did not loosen up earlier, so that was not good. I maybe have to use 5mm threading instead and go at the side of this bolt here, so I don't interfere with it. Alright, let's go in again. This will be just fine. I will also make sure that this is all sealed up when I put it together. Now I just will install it to the firewall here. I mean, it's not perfect in any way, but it's pretty good anyway. I used to save all those old hoses when we are changing stuff like those out on my work, so therefore I had a lot of those laying around. You never know when you need them, especially when you do a project like this. It's really good to have them around. Alright, so all the hoses are now connected, or not all the hoses, I have one left here. So I was talking about to have two separate systems earlier here, but I tried this with just pure water yesterday evening, and it seems like there will not be any heat over to the other side here, because this is circulating in only this hose here. Pressure and suction are always going to cancelling the flow out here, so it will not jump over to this canister here if I am attaching it here, because then I only need one canister and that's what I want. So there will be a little special procedure when I am going to bleed this system, because as you can see I don't have any bleeding hose as I have with this one. So I am going to close off the whole cooling system to the motor and set this heating side under vacuum. And then I am going to apply coolant fluid after that. So one heating system and one cooling system are on the same expansion tank. It's now a few hours later and the relay are now sitting here, and that control circuit that I have built for it are laying down there. You can see the transistor there. So here we have the power for the heater into the relay and then out again, and the connector to the heater are laying down there. I have not connected it yet, and the other terminal is going straight to that connector down there. And let's go into the car here and show you what I have done here. So I will turn on the whole system by pressing this rear window heater. So when doing so, then I will activate both the circulation pump and that little circuit and the relay that I have put into the PDM unit in front there. So it's now time to fill up the system with some coolant fluid, and then I am going to evacuate all the air in the system before I do that. So what I have done now is that I have closed this hose up with this clamp here. So I cannot have any vacuum into this cooling system, and I don't want that because this is perfectly free from air right now. So I am going to suck vacuum from the expansion tank, and then it will spread out to the hoses and the heat exchanger here on this side. So I will pretty much get out all of the air from that system, I hope. So sadly I am missing a connector here, but I have worked my way around it anyway. So I will close this up. I have now prepared everything, so I have a bucket of coolant fluid down there, my vacuum pump, and we have that little vacuum meter there. So I am now going to apply some vacuum on it, and hopefully it will work. And I have also a clamp over here, so I will first apply some vacuum and then I will bleed this hose off, because now it's air all the way down to the bucket there. So first of all we need to bleed that. So I will start to open the valve here, and now you can hear that we are sucking some air out. You can see at that gauge also. Let's turn that off for a second. So now I will open up this clamp and you will hear how the antifreeze will flow up into this hose here. So what I did now was that I opened this clamp, and when I did that, the coolant fluid traveled all the way up into the house to this clamp, and then I shut it tight again. So now we have bleeded this hose off, so we have vacuum here and fluid directly on the other side of this clamp here. So now I just will evacuate the rest of the air. Okay, we have a good sealing there, so let's open up. We have to wait so we don't hear any different in sound between open and close here. So no, it's perfectly fine. So let's shut this down. And I have to close it because I need to fill it up with some water. So I will now start the circulation pump here. I have not connected the heater yet, so I don't heat anything up here, because if there is any air bubbles around the heating elements inside of this heater, well, those elements will just burn up, so I have to wait with that. So I will simply just turn on the ignition and see if the pump will start there, and then we'll listen to the system how it sounds, and hopefully there will not be too much air inside of the system. Yeah, it circulates. It sounds pretty good. I mean, if there is any bubble up here, that's not a big problem. I don't want them inside here. So now you can hear that we don't have any air left in the pump there. It's completely quiet, but I guess that it maybe will come back if I... Oh, it seems pretty good. Alright, so I think it's time to put on the power to the heater here. So I will just connect that first. Power on in 3, 2, 1. Yes, it's getting hot. It seems to be working. Alright, so I just took the car on the outside, and here are the conditions. So you can see that we have a 14 degrees inside of the car, and here is where I have the probe, just in the center air outlet. So inside will be outside sort of right now. So we have a 3 degrees right here at the windscreen and 14.2 degrees on the inside. Let's see where it will be best. Probably on this hose here. Yeah, 20 degrees. So I will just start this heating up and see what kind of temperatures we will have then. Ignition on, and we turn on. This is the button for the heating. So on with that one, and the fan on the second stage. So let's go out and see what kind of temperatures we have there. Yeah, it starts to raise up. And now I heard that the relay turned off. So let's see if it will go down. And yes, it does. And there it turns on again. Yeah. And there it's off again. It works so fine. And we have 39 degrees inside of the car and only 2.6 degrees on the outside. So this is far over my expectations. So here we have the sensor. I have just thrown it inside there. So let's turn it off. And the temperature will then of course start to go down again. So 40 degrees right now, 40.3. That's probably the highest. Maybe I reach another area in the outlet there, I don't know. But now it starts to go down. And it's perfect to do this now when it is cold like it is now. I mean, now we really can see that this actually works. Alright, great! Well, this works so much better than I had expected, and now I just have to do some coding to my arduino and later on use that to control this relay with some precision instead, so we don't have any arcing and stuff. But I have to say that this seems to work really good as it is, so I maybe not have to do that, but I think I will do it anyway. So alright guys, I know that this video was a little bit long, but sometimes it has to be that way too. So anyway guys, thank you so much for watching. I really hope that I see you next time. Take care and goodbye.